Here live, guys. Can you guys hear me? Am I audible? Hear me? Yes, you can. Hello, guys. Welcome. Welcome to the one of the final, almost the final part of current electricity. Before we go any further, I want all of you guys to maintain social distancing, stay at home, and stay safe. Okay. I know this is tough time for everyone, but then that is why we are here for you, Unacademy here. That is why Unacademy is here for you. Before we get any vaccine, I want all of you guys to keep your distance. Don't start roaming around saying it's over, it's over. क्योंकि अभी picture बाकी है मेरे दोस्त. You can see the other countries how they are responding to it. How tough the situation has become. US has got 1 lakh cases in single day. This is their highest in across till now, till date. A lot of them are starting second lockdown and all also. So stay safe, guys. Stay at home. Stay safe. Keep your distance and crack IIT-JEE with India's largest platform, which is Unacademy, right? Crack IIT-JEE with India's largest platform, which is Unacademy for sure. You get the subscription using the code NSS1 and enjoy unlimited benefits. Okay. So this is how the app will look, guys. Install the app right away. We have lots of fun in the app, which have the daily quiz show, which is happening today. The daily quiz show, the 14th episode. I don't know even how to write Roman numerals now. That's the number of episodes we've got till now. The daily question number 14. Okay, so definitely be there. It's going to be a lot of fun. We have loads of quizzes coming up for you. We have loads of fun there. Everything will happen dynamically. So what are you waiting for? Go for it right away. So about me, guys. Hello, I am N Srikant. I did my BTech from IIT Kharagpur. I have an AIR of 385. I got an AIR of 385. I've been guiding you guys for the last 5 years. You guys call me human calculator. Yes, I'm a Sunrisers fan. Finally, it's good to say that. Okay. Finally, it's good to say I'm a Sunrisers fan. And DC is equally marvelous, if not better. I'm a huge DC fan. And if you have anything else to say about this, feel free to put it in the comment section. This is an exclusive channel for those. This is Let's Crack IIT-JEE in English. This channel is exclusive for those guys who have tough times understanding Hindi. So we will discuss most of it only in English, so that those who have trouble understanding Hindi, they can come here and listen to the entire course in English. So what are you waiting for? Just hit the share button and share it to your friends, so that anyone who has trouble with Hindi or any other language and who are only comfortable you guys to help you crack IIT-JEE. So what are we waiting for? What are we waiting for? Let's go for it right away. अरे क्लास लो ना. We are back again. थोड़ा छोटा सा इश्यू था. So this is the program I've launched for you guys. This is called Ad Astra. Ad Astra means aim for the stars. So let's aim for the stars and crack IIT-JEE, because it's all logical. If you ask me, everything is the same. So when you have the bigger perspective, when you dream big, you do big. Remember, dream big, do big. That's it. So this is the 8th episode of Current Electricity, where we'll be discussing about we will be discussing a lot of problems and a lot of problems basically. Okay, so ये general एक must diagram है. This encapsulates everything which is good about current electricity. This will give you full clarity. This is the positive side and this is the negative side. As you see clearly, the current flows from negative side to positive side. There is an increase in potential, and across resistances there will be a drop in potential. Always from positive, anywhere when the current moves from negative to positive is always above higher. The potential will increase. Always from negative to positive, the potential will increase. Hello Ramesh, welcome. So today we have a quiz, by the way. Ramesh, today we will be having a quiz at 10:30 as usual. So definitely be there. Okay. So before we go further, little about power. What is power? Power is the rate of work done by battery. We already discussed about power previously. It is the rate of work done by battery. It is also the rate of heat dissipated by the electric circuit. So using these both, you can say that law of conservation of energy is being followed, because there is no new energy work done by the battery. If there is work done with the battery, it should come out in some form. Okay, that coming out is only in the form of heat. That is only equal to the heat dissipated. Work done is equal to the heat dissipated. So using these both, we can also say the power definition is equal to V square by R, or is also equal to V into I. It is also equal to I square R. All these are being used. Okay, this is the definition for power. Yes, the flash is there. The unit is watt. What? Very common cliche joke, but okay, it works all the time. What works all the time? What? It works all the time. Okay. So unit is watt, and which is also 1 joules per second. In real life, what we use is 1 unit. 1 unit is 1 kilowatt hour. What is the meaning of 1 kilowatt hour? 1 kilowatt hour is 1 kilowatts into 1 hour. This is power into time. Okay, this is a form of energy. Okay, 1 unit means 1 kilowatt for 1 hour continuously, which means it is a form of energy. 1 kilowatt hour is nothing but 1000 into 3006, which is 3.6 into 10 to the power 6 joules. It is also 3.6 megajoules. All right, this is the form of energy where 10 power 3 is 1 kilowatt is 10 power 3 watts, and 1 hour is 3600 seconds. You multiply both of them, you get this is watts and this is seconds. So watts into seconds is joules. Basically joules per second is watts, so watt into second is joules. So ऐसे ही हो गया. तो ये क्या है? ये form of energy है. It is the form of energy. It's a measure of energy. It's not form. It's a measure of energy consumed. All right, awesome. Now let's go to the next part. So today we will be discussing about a few few instruments. All right. The first one we are going to start off is galvanometer. Galvanometer is an instrument used to measure the strength of current by measuring deflection in a coil due to torque produced by the magnetic field. This is known as galvanometer. A galvanometer measures the deflection of coil due to torque. So when it uses the magnetic effects of current. It uses the magnetic effects of current, which we will be discussing as we go. We will learn about how it gets affected. It uses the magnetic effects of current to produce torque. A torque जो है, because of this torque, the galvanometer needle will shift here and there, as a result of which it can measure the strength of current. It is also used to measure. It is used to measure both current and temperature. No, this is not temperature. Voltage. It is used to measure both current and voltage. Okay, it's not temperature. Temperature kahan se aa gayi? All right. So there are two ways of using it. One, current galvanometer can be used as an ammeter. Next way, galvanometer can be used as a voltmeter. Now, any device which measures current is called device measuring current will be called as ammeter. ठीक है? This is called as ammeter. Ammeter. Okay. Current is an ammeter. Amps, no? Current is an amp, so this will be ammeter, and device measuring voltage will be called voltmeter. So these are general standard names, guys. ये both already all of you must be knowing this, but then just give it so that you can understand it and feel just a little revision time. So that is about it. So now there is also one thing called shunt. Okay, the small resistance connected in parallel to galvanometer in order to control the current flow through the galvanometer. So what the main point is, galvanometer is very it has a very limited range of current flow. Okay, you cannot just let lot of current flow through it. So what happens is a shunt is applied in parallel to galvanometer. It is applied in parallel to a galvanometer. तो ऐसा होगा, ये galvanometer है, तो a shunt resistance is applied in parallel to this, so that जो current है it will flow along both directions, as a result of which the effect on galvanometer will be it will save the galvanometer basically. So what are the advantages of it? It is used to protect the galvanometer. Any galvanometer, it protect the galvanometer from burning. That's what I told you. When too much current flows through a galvanometer, it will catch fire. It is on fire. It is always active. It is always on fire. So, to stop this from actually catching fire, the galvanometer, you need to have a shunt in parallel. And any galvanometer can be converted to an ammeter. This is one more very important point. It can be converted to an ammeter of desired range with the help of a shunt. This is only the concept of ammeter. We'll be discussing this just in a couple of slides. Okay, and the range of ammeter can also be changed. So if you want, if you have a very small shunt, the range of current will become more. If you have very big, more resistance in a shunt, the range of current will decrease. How, we will discuss in the coming slides. So the range of ammeter can also be changed using this shunt. So that is the advantage of it. But the demerits is that it will make the whole setup a little more insensitive. क्योंकि ज़्यादा current इधर उधर, the amount of current flowing through both of them will increase. As a result of which, the quality of the galvanometer or the sensitivity, the accuracy decrease होगा. It will reduce accuracy, but it will also increase a lot of durability. It increases durability and flexibility. तो ऐसा है, इट्स लाइक एन आर्मर. मतलब जैसे कि तुम लोग पबजी ये सब में देखते हो ना, यू हैव वन आर्मर विच विल इंक्रीज योर स्पीड, one armor which will increase your flexibility, one armor which will increase your shoot power, all those things. ऐसे shunt is for a galvanometer. It will reduce accuracy, but it will increase durability and flexibility. All right. So conversion of galvanometer into ammeter, just like we discussed previously, the galvanometer can be converted into an ammeter by just connecting a low resistance parallel to its coil. This low resistance is also called as shunt. Understood. So that is what is given here. It is also called as by a shunt, as we just discussed. So it is a shunt. So what happens where value of shunt resistance to be connected in parallel to the galvanometer, its coil is given by Rs is equal to Rg into Ig by I minus Ig. So ये simple है, काफी straightforward है. Ig is the current flowing through galvanometer it can measure, and Rg we also measure. So what do we know? They both are in parallel. So we know the potential difference is same, which implies I minus Ig into Rs will be equal to Ig into Rg. So as per the diagram, so directly you can get R shunt value will be equal to Ig Rg by I minus Ig. Voila, wonderful. Simple hai guys. This is a very basic explanation of it, but then we will discuss more as we solve problems. Okay. I is the range of ammeter. So what we discuss here is I is the range of ammeter. All right, and Ig is the current required for deflection in the galvanometer, and Rg is the resistance of the galvanometer. From this only you can understand, if the shunt value increases, which means the denominator will decrease, which means the range of ammeter will reduce. As R shunt increases, range of galvanometer simple, no. So no, range of galvanometer does not decrease. As R shunt increases, the Ig whatever is there. So one thing you have to understand, as shunt resistance increases, more current will flow through Ig. No? As shunt resistance increases, Ig will increase. No, first thing you know, Ig will increase relatively, which implies I will also increase. Only then the Rs will remain that much. Understood? So simple concept है. इसमें एक concept fixed है. The Ig, which is the current flowing through the galvanometer, will have a fixed maximum value. Understood? It will have a fixed maximum value. उससे ज़्यादा होगा तो it will start burning up, like we discussed. Okay, I will as we discussed, it will start catching fire. So as the shunt resistance increases, this the amount of current flowing through this will increase. Getting it? The current flowing through this will increase, as a result of which the I will also reduce. Okay? So a range of ammeter will reduce with the shunt. All right. So now the next method is the conversion of galvanometer into a voltmeter. The galvanometer can be converted into a voltmeter by connecting high resistance in series with its coil. So main high resistance क्यों लगाते हैं? Same concept, so that the current through the galvanometer will be controlled. High resistance is used to control the I through galvanometer. Always remember, I through galvanometer should be controlled. Only then will it work very successfully. Okay. So high resistance will be used. High resistances will be used exactly in series, that too, so that the total effect will reduce. So now what will happen is you need to measure the potential difference across this. We have a circuit, some circuit here, some set of resistances, and some other sets are also there. Something, and they are measured across the potential difference. Let's say they are measured across the potential difference. Now what will apply is this is where the galvanometer will be connected. When this is connected, it will calculate the potential difference across these. And one more advantage is when this resistance is too high, the amount of current flowing through this will also reduce, as a result of which it will become little more accurate. The problem with this only is that accuracy is missing a lot of times. Okay, it will not be very accurate. That is why we use better methods like potentiometer and all. But then if you want to measure the current here, the resistance should be very high such that this current will become very low and it won't disturb the entire circuit. Okay, so ये potential difference जितना भी है, the potential difference can be defined as I into R plus RG. तो इससे resistance value कितना आ जाएगा? V by I minus RG will be equal to the V by IG, क्योंकि IG है, current flowing is IG. So is it clear, guys? Awesome. So now let's एक और बात समझ लो. Potential. So this setup will be placed parallel to the circuit. This is the most important point. To find the potential difference across a couple of joints, this voltmeter is connected across the 2 points, and that potential difference will be calculated by using this concept. Is it clear, guys? Alright, if you like this video, definitely hit the like button and share this everywhere, so that everyone who has trouble, who wants to listen to this only in English, will listen to this channel and will listen to this video and hopefully get a lot of information and crack IIT-JEE with that. So now let's talk about a few problems. Find the reading in the galvanometer when it acts like a voltmeter as shown in the figure. The figure seems to be missing. It acts like a figure as shown in the figure is 20 volts. It acts like a voltmeter like this. So ऐसा है 24 volts. This battery is 24 volt battery. All right. This RG is 30 ohms, and this is connected across. This is connected like this along with so it is used to measure this galvanometer used to measure the potential difference across. So the reading of this galvanometer is showing 20 volts. So what is the value of this resistance? That is the question here. Alright, let's solve this question right away. अब इसमें क्या है? This galvanometer is in series with this, so it will measure the potential difference across this end and this end. It will measure the potential difference across ends A and B. This potential galvanometer will measure, it's act like a voltmeter and measures potential across AB. This will be equal to how much? It will be equal to R plus 30 into I galvanometer. And one more thing we know, so this is equal to 20 volts, right? And one more thing we know, IG into 36 volts will be equal to this potential difference, which is equal to 4 volts. Getting it? that in 36 ohms is equal to 4 volts, which means what we get Ig value is 4 by 36, which is equal to 1 by 9 amperes. So the total current flowing through this is 1 by 9, and we also get R plus 30 into 1 by 9 is equal to 20. इससे क्या होगा? R plus 30 is equal to 180 होगा, तो R value कितना होगा? 150 ohms. That is the right answer. The answer given for the given question is option D. Great job, guys. Most of you already solved this problem. So great job. Let's go to the next topic. So next, just a little small question on this, and then let's go to the meter bridge. This is where the things get interesting. It is based on the principle of Wheatstone bridge. ठीक है, it's based on the principle of Wheatstone bridge. इसमें क्या है Wheatstone bridge? ये एक resistance है, इस side एक resistance है. Similarly, there is one resistance on this side and one resistance on this side. The condition is the condition for Wheatstone bridge in this particular case will be RB, the resistance of the RB by resistance of P will be equal to resistance of S by 100 by resistance of this. So resistance of L and resistance of 100 minus L. And resistance is proportional to length. We know resistance is proportional to length. It is rho L by A. So we'll directly write RB by resistance of S will be equal to RB by L will be equal to resistance of S by 100 minus L. So इससे हम we can solve all problems using this. So that is exactly what is given here. So इसमें we can solve it and you'll get the answer. This P by Q will be equal to R by S. So RL by R into 100 minus L will be equal to R by S. Yes, which is what we got. R and R will get cancelled. So we will get the RS will be equal to 100 minus L by L into RB, which is what we just derived and which is what we also got here. The resistance we want to find out will be equal to 100 minus L by L into RB. Clear? That's all. At balanced condition, this is what happens when the reading of galvanometer. In this condition, the reading of the galvanometer will be equal to how much? Will be equal to 0. Clear? So reading of the galvanometer will be 0 when it becomes a balanced Wheatstone bridge. When the potential difference between B and D will become 0. When BBD is equal to 0. It will become a Wheatstone bridge. When based on the Wheatstone bridge condition, we can find out the resistance which we want to find out by using the above formula or by using the concept of Wheatstone bridge. That will anyways work. Okay, a galvanometer reads 0 current, which means it is in a balanced Wheatstone bridge condition when meter bridge is at 27 centimeters below the resistance. Okay, मतलब यहाँ पे resistance एक ऐसा है, यहाँ पे कुछ और RB है, and this wire when it's at 25 centimeters, the galvanometer is reading 0. All right, like this. तो ये मीटर ब्रिज में है तो ये 25 है तो ये इसका वैल्यू 75 हो गया, वो बाद में देखेंगे. How many such resistances will be in series will make the galvanometer read 0 at 50 centimeters? So now I put some n such resistances in series. तो इसका total resistance कितना हो गया? NR हो गया and इसका RB already है. All right, and now the galvanometer will read 0 deflection at 50 centimeters. तो फर्स्ट वाला लिख दो, R by RB will be equal to 25 by 75, which is equal to 1 by 3. Let's see how many of you answered it before I do. And now n in series, so you can say NR by RB will be equal to 50 by 50. So R by RB is equal to 1 by 3. तो इसमें ये सीधा लिख दूंगे n into 1 by 3 is equal to 1. तो n कितना हुआ? 3. Voila, simple question to start off, guys. Great job, wonderful answering. So let's go to the next question. The value of resistance and when galvanometer reads 0 current in the given figure. Given length is 40 centimeters, L is 40 centimeters and RB is 100 ohms. So what is the value of resistance R for which the current L reads 0 at 40 centimeters? So simply equation लिख दो. RB by RS is equal to L by 100 minus L. Or we can directly use the formula here. Formula क्या है? RS is equal to RB into 100 minus L by L. सब्स्टिट्यूट कर लो सीधा. RB का वैल्यू 100 है, 100 minus L is 60, down it is 40, zupak, 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 zupak. This is coming out to 150 ohms. So this is great solution, great answer, great job guys. How many of you have done faster than me? Well, great job. Those who have done faster than me, you've done great. Now the answer for this question is option B. Got it? है ना मस्त एकदम simple सा concept हो गया. Everyone are clear with this? All right. Now let's go to another question of this sort. Everywhere will just keep changing it. Okay. The reading of the potentiometer across the galvanometer given RB is equal to S and the length is 25 meters. So reading of the potential difference. One thing we know here, galvanometer will behave like a voltmeter. One thing, the main advantage of this is galvanometer can measure it in both voltmeter and as a as an ammeter. So in the previous questions when it was working as a Wheatstone bridge, the voltmeter reading or the ammeter reading will be 0. But in this particular question, I want you to find out the reading of the galvanometer when these both are equal. Okay, कितना होगा करके we will find out now. Assuming it to be ideal, the main assuming we'll do is assuming this is an ideal galvanometer, ideal voltmeter करके assume करते हैं. This is the basic assumption with which we'll solve. But most of the cases this does not happen. Voltmeter does, it's not ideal voltmeter. But then let's find it out taking it as ideal. What is the condition for ideal voltmeter? Okay, so we'll discuss about these things after this question. The condition for ideal voltmeter is the current across it will be equal to 0, or we can also say the resistance will approximately be equal to infinity. Resistance tends to infinity. The condition for ideal. There is no current flowing through this, is only measuring the potential difference. So when RB is equal to S, what does this imply? Potential is equally split, which implies velocity at D, potential at D will be equal to V by 2. Got it? And similarly, now velocity, the potential difference, potential difference at J will be proportional to 100 minus L. So if you observe carefully, this potential here is V, here potential is 0, here potential is Vj. It can say V minus Vj by Vj minus 0 will be equal to length by 100 minus L. इसको equate कर दो, V minus Vj by Vj is equal to 25 by 75, which is equal to 1 by 3. इससे क्या आ गया? Vj will be equal to 3V by 4 Vj is equal to 3 Vj. From this we'll get Vj is equal to 3V by 4. So we got Vj to be 3V by 4 and Vd to be V by 2. So what is the potential difference across these both? Vj minus Vd will be equal to 3V by 4 minus V by 2. कितना हुआ ये? V by 4 हो गया. The answer here is V by 4. कितने लोग मेरे से जल्दी किए? ओके, गुड वन, आराम से करो, there is no hurry. All right, so from this just now we discussed that the voltmeter has, give me one moment guys. Galvanometer behaving like a voltmeter is not absolutely ideal. Okay, it is not always ideal. कभी कभी इसका voltage मतलब it won't behave ideally, it will behave little more like the potential across this will drop because there will be current flow and there will be voltage drop across the galvanometer also. So now we will discuss about ideal cases. We will discuss about ideal voltmeter क्या करता है, ideal ammeter क्या करता है. Ideal voltmeter will only measure voltage difference without affecting current. का मतलब क्या है? It will not affect the current at all. It will be placed, ideal voltmeter will be placed in parallel. ये किस में placed होगा? It will be parallel to the circuit. तो कैसा होगा? कुछ भी कोई रेजिस्टेंस के अक्रॉस कैलकुलेट करना है तो दिस इज वेयर द वोल्ट मीटर विल बी प्लेस्ड. एन आइडियल वोल्ट मीटर This is the symbol of it, voltmeter ka. Ideal voltmeter will have resistance is equal to infinity. If resistance is infinity, it won't affect the circuit because R effective here will become how much? R voltmeter into R of the circuit by R voltmeter plus R circuit. So if you look at it this way, इसमें क्या है, RV this will approximately be gone, तो RV cancel हो गया, R effective will approximately be equal to RC हो गया ना, R circuit का. So ideal voltmeter will have R of ideal voltmeter will be equal to infinity. Otherwise, R of voltmeter will be very high. Okay. Next, we will discuss about ideal ammeter. It used to measure current flow without affecting voltage. Basically, एकदम simple है, उसका उल्टा है. Voltmeter should not affect voltage. Ammeter should not affect. Voltmeter should not affect current, and ammeter should not affect voltage. So it will measure current without affecting voltage. It is placed in series to circuit. तभी ना it will find out value. So if you observe carefully, this is how it will look. Ammeter will have this symbol. Symbol is A, and it is also an ideal ammeter here. Ideal ammeter means it won't affect the current. So what is the ideal ammeters? Ideal ammeters. Resistance of an ammeter will be approximately equal to 0. Okay. So it will always be R of an ammeter will generally be very less. So these are the main points you can understand and note down, guys. So that is about ideal voltmeter and ammeter. So Filal, we won't discuss about what ideal situation it is, but then galvanometer will roughly give you the idea of an approximate voltmeter. Voltmeter may across the galvanometer it will be connected with another extra resistance which is very high, and for an ammeter the galvanometer will be connected with with a current with a small resistance shunt resistance in parallel. All right, that way they can make this closer to ideal scenarios. All right, तो बस यहाँ पे बहुत errors है. Galvanometer will not produce perfect results, so most of the cases a potentiometer will be used. The advantages and disadvantages we'll discuss now. How the potentiometer works also we will discuss in this given situation. So practically voltmeter will have finite resistance. Ideally it should be infinity, and in other words it draws some current from the circuit to overcome the this problem. Potentiometer is used because at the instant of measurement it draws no current from the circuit. Wow, देखिए, it draws no current. It means its effective resistance is infinite. The main advantage of potentiometer is it does not draw current from the circuit. It does not draw current. Because any circuit it will draw current generally. If you link it to a circuit, it should draw current. But the main advantage of this is it will not draw current. The working principle is any unknown potential difference is balanced on a known potential difference which is uniformly distributed over an entire length of potentiometer wire. Wow. This will use the concept of meter bridge and galvanometer both together. It will work like wonders. This process is named as zero deflection or null deflection method. Exactly. Null deflection मतलब क्या होता है? करंट नहीं होता, फ्लो होता है. ठीक है. Now it contains, so what is the working of it before you go to the diagram? It will contain a potentiometer wire. This is the wire across which this will be connected. It is made up of alloys of magnesium, constant and eureka. Specific materials or specific properties of these alloys are high specific resistance. मान लो it will be having very high specific resistance and negligible temperature coefficient. It will not change with temperature and it will have high specific resistance. The invariability of resistance of potentiometer wire over a long period. It will not get changed over a long period of time or heat. it should also have high melting point. Okay, potentiometer using the length of इसका circuit. Let me draw it and show it. ये primary circuit जो है, let's take some circuit which has some current, some current flowing. We don't know how much the current is, or something like this is there. Let me draw a better diagram. So there is a potential difference, and I want to find potential difference across some other EMF like this given. Let's say I want to find the potential difference across this end. So what I will do is I will connect this entire thing. Let me draw a better diagram. I will draw it from top. Now what a potentiometer does is, this is connected across the wires of a potential. This is connected across wires which we discussed. All right. So this will be passed across a wire as shown in this particular diagram. So from this wire is only called as potentiometer wire. Called as potentiometer wire. Everything else is of negligible thickness. Now this wire is not separate. This is just a very small resistance wire. This is the potentiometer wire as shown here. This will be the potentiometer wire. Okay, awesome, right? This is called the potentiometer wire. Now what will happen is, there is a third circuit. This is a secondary circuit. Now this is the primary circuit, we all know. Now potential difference across this will be equal to potential here. If I want to find the potential across this, okay, this potential will be equal to this potential. Now what happens is, another secondary circuit is connected in parallel to this, and this is also connected somewhere here. This whole distance will be understood. So इससे क्या होगा? By logic of linear concept, by linear logic, we can say this is secondary circuit with known potential difference, known V. So from this we can say V by known velocity, known potential difference. So let's call this potential difference across this to be known potential difference, which is equal to some, let's take velocity of secondary circuit, the potential energy of secondary circuit. So we can say potential of secondary circuit by potential total will be equal to X by L. So we can also say V will be equal to Vs into L by X. Clear? So it's very simple, guys. एकदम इसी logic से हो जाता है. So take the circuit. You know the potential difference will be proportional to IR, and V total will be equal to I into V total will be equal to I into L, and V secondary will be equal to I into X. तो इन दोनों को डिवाइड कर दो, सीधा ये आ जाएगा. Understood? There will be a current flowing through this also, but then it will be very negligible, and current flowing through this will be equal to 0, because the deflection should show null. Deflection is equal to, yes, I hope this is clear, guys. The deflection will be a null vector. It will be a null value. It will be 0. That is why it is called as null method. Jab deflection 0 hoga, then the potential difference across this secondary circuit will be equal to the potential difference across this. Vs will be equal to this, and similarly V will be equal to I into L. तो ये दोनों equation को हम अलग से फिर से लिख सकते हैं. From these diagram you will get Vs will be equal to I into X, and V will be equal to I into L. Using these both, we will get V is equal to Vs into IL by X. I hope this is clear to you guys. Awesome. Moving coin galvanometer. I didn't have that in this. We will discuss that in the next class. I'll definitely work on that. I will write down and I'll tell you. Moving coin galvanometer. So these meters I'm just telling so that you will get. Hello Saket. Hello physics. Welcome. Finally, it's been a while. I've taken a small break. थोड़ा technical issue हुआ, but we are all good now. We have a new laptop also. Very excited about it. So this is about a potentiometer, this is how it works. Understood? So इसमें एक छोटा सा क्वेश्चन कर लेते हैं. So now that you guys are here, let's solve this problem. Let's see who does faster. Okay, I've decided not to put the timer today. I will just solve the problems because there are so many problems today. So many problems today. Life पूरा आज problems ही है. All right. Yes. For a secondary voltage of 20 volts, let's see this. There is some voltage we need to find out, and then there is this potentiometer wire like this. We'll just draw the diagram. Okay. And the secondary voltage is 20 volts. It's given. The value of current through a 5 ohm resistance such that the potentiometer is balanced at half length. ये half length मतलब ये 20 होगा तो ये 20 होगा, which means the potential total difference across this should be 40 volts. हो गया. तो करंट कितना होगा? The total potential difference across this is 40 volts and it is balanced through a 5 ohm resistance. So there is a 5 ohm resistance here. So what can we say? I into R is equal to 40 volts, which implies I into 5 will be 40 or I will be equal to 8. Is it clear? Good one. Most of you who've seen this have got it. Great job, guys. Now let's go to the next question. There is a definite potential difference between two ends of a potentiometer. All right. Two cells are connected in such a way that the first time help each other and second time they oppose each other. A definite potential is maintained across two ends of a potentiometer. So across two ends of a potentiometer, the length will take length to be L. The potential is fixed. And when two cells are balanced, they help each other. The length is coming out to, when two cells are connected like this, let's call them V1 and V2. They together meet at 120 centimeters. That's what they say. And when they oppose each other, we'll change the instead of changing the diagram and just when they oppose each other, like when one is like this and the other is like this, the reading will null at 60 centimeters. थोड़ा better लिख देते हैं. We'll draw a better diagram for this. But a बहुत easy question है. If you can solve this, you can solve it quicker than me because I'm making effort to draw the diagram very neatly. A wire like this. Yes, thank you, man. This is because of the new laptop. The new laptop had a new blackboard effect, which I really loved. That's why I'm using this blackboard. So if you like it, definitely hit the like button. I want you guys to share it. From now, we'll have videos like this only in this blackboard. I'm very excited. I'm as excited as you. Thank you for telling it. I was very excited about it, seriously. Yo, awesome. Now let's take two of them in series. When they are adding to each other, the reading is showing at 120 centimeters. And when they are opposing each other, like this, then the reading is showing at 60. So here the effective potential difference is V1 plus V2. Here it will be V1 minus V2. First we'll solve off. V1 plus V2, let's take the whole resistance to be R and the total potential to be V. V1 plus V2 by V will be equal to 120 by length L. Taking the total length to be L. Total length is L. तो इससे क्या लिखेंगे? V1 plus V2 by V will be equal to 120 by L and V1 minus V2 by V is equal to 60 by L. Just divide both of them. Equation 1, equation 2. Just do 1 by 2. Scoop नहीं है. V1 plus V2 by V1 minus V2 is equal to 2 by 120 by 60, which is equal to 2. तो इससे क्या आ गया? 2V1 plus 2V2 is equal to 2 V1 minus V2. Hey, no. Is equal to V1 plus V2. इससे क्या आ गया? V1 is equal to 3V2. Means V1 by V2 should be equal to 3. Answer is B. Thank you guys. So great job. Now let's go to the next concept. So now up to today we discussed about potentiometer and a voltmeter and a galvanometer. Voltmeter is nothing but it's a galvanometer in galvanometer. So the main disadvantages of a galvanometer and let's see. So potentiometer, the main thing is it measures the unknown EMF very accurately. Okay, while measuring EMF, it does not draw any current from the driving source of known EMF. That is a very big advantage here. It will not derive any extra current from the source. As a result of which, the circuit will not get impacted. You can just use this potentiometer without affecting the circuit whatsoever. But on voltmeter, on the other hand, it measures the unknown EMF approximately. We just discussed in the beginning only that it will be approximate. It won't be exact. Understood? Because it is not exact at all. Like there is a lot of current it draws, and it is also, if you connect any galvanometer, it has finite resistance which will affect everything. While measuring EMF, it also draws some current from the EMF source, as a result of which even the EMF will change. While measuring, then the third point is, while measuring the unknown potential difference, the resistance of potentiometer becomes infinite. So this will behave like ideal, but while measuring unknown potential difference, the resistance of voltmeters are high but finite, which is exactly what we discussed. This is based on zero deflection method. It is based on deflection. This thing will be based only on deflection method. मतलब deflection होने पे ही you can calculate. On the other hand, in potentiometer, if deflection does not happen, then you can measure. And it has very high sensitivity, and this sensitivity low because you are adding shunt and all. It is used for application with measurement of internal resistances, of cell calibration of ammeter and voltmeter, measurement of thermo EMF, all these things. It is used to measure EMF of unknown potential difference. So this is a little about potentiometer, voltmeter, and all about what we know, basics of measuring devices. Okay. So I hope you liked it, guys. If you liked it, definitely hit the like button, share button, and crack IIT-JEE in English. Hit the subscription to the channel. And while you're doing it, crack IIT-JEE with India's largest platform, which is Unacademy. Get the plus subscription to access unlimited live and recorded courses from India's best educators. Remember this code NSS1. NSS1 is the code, is the magic code with which you can get wonderful offers. So let's talk a little about plus subscription. The plus subscription will give you access to the best of Unacademy, where you get daily live classes. Daily live class means where you can chat with your educator, engage in discussions, ask your doubts, and involve in polls all while the class is going on. This is a wonderful effect. We have a daily live class which is called as a daily quiz show. I'm having it at 10:30 p.m. today, so do come into that. You can search for my name N Srikant, or you can also search for the daily quiz show number 14. जो आज चलने वाला है, it is daily quiz show number 14. So we will have a daily quiz show like before. We have loads of fun there, where we also engage in all these things. Where you have an educator, where I'm going to engage in discussion with you. I'll clear your doubts and also give you polls all while the class is going on. You have live tests and quizzes, evaluate your preparation with our regular mock tests and quizzes, and get detailed analysis of your performance. There are also already pre-made quizzes and tests already in the app. Once you take the plus subscription, you get all the pre-made quizzes ready for you, which you can take at your convenience. All right. And then you have structured courses, where entire syllabus is given to you in a structured set, a class by class approach. Like we are having current electricity 8 here. There is also this similar and much more consistent approach there, where everything is given right away. It's not like live happening there. So those things you will have recorded sessions as well as live sessions, both happening on the go. So structured course will be there, all in line with your examination pattern and examination syllabus. And you get one subscription, you get access to all the live and recorded courses from all the best teachers in the entire country. From best of Unacademy, you will get the best of Unacademy. That's that's the underlining statement, which is actually the underlying statement here. You get access to the best of Unacademy. So the cost of this is 38,500 for 1 year. Okay, but use the code NSS1 to get extra 10% off, which is amazing, and you get it for 34,000. You get it for below 35k. EMI options are also available. No cost EMI options are available. And for 12 months, you might think it might be expensive, but after using the code, this comes out to 2,888 rupees per month for physics, chemistry, and mathematics, which is nothing but 32 rupees per day on physics, chemistry, and maths. तो मतलब 32 rupees में आजकल क्या मिल रहा है? कुछ नहीं. So what are you waiting for? Just go for it, guys. Awesome. And next, not only that, if you're cracking JEE in 2022, तो अभी काफी दूर है. So 12 months को बदौलत you can take 24 months. Why I'm telling this 24 months is because 12 plus 6, the cost of 12 plus 6 is greater than 24. So abhi say if you want to take 6 months also, 6 and 12, it will be much greater than 24 months. So you can just take 24 months right away. And here also 6 months cost is 28k. And if you use the code NSS1, you get it for 25.2k. So remember guys, 6 months is for 25.2k. What are you waiting for? It's awesome, and let's go for it. The cost of this is 50,400. By the way, this comes out to 23 rupees per day. Matlab, 23 rupees per day on physics, chemistry, and mathematics is pretty awesome. All right. Next, coming to the iconic subscription, this is the closest to the classroom program that has been launched by Unacademy. Take your IIT-JEE preparation to the next level with a personal coach. That is the new USP this Unacademy's iconic subscription has. A personal coach is an expert guidance guy. Like, he knows, he's been guiding students like you guys for the last so many years, and he will give you personal coaching and align you with your preparation strategy. He will analyze how you're doing, what is your strength, what is your weakness, and then give you particular preparation strategy based on that. Not only that, you will get in-depth test analysis for all the quizzes you take, and you will also be given a study planner which is weekly or bi-weekly, which will be optimized for best results. मतलब ये study planner तो it is optimal to give optimal performance to you guys. ठीक है, तो इसमें so this is for those guys who need help from teachers. Like most of you students, when you are in school, you always took help of teachers for any problem or any general how to prepare, what to prepare questions. I know a lot of students come to me with that. So I know a lot of you want this. So this is the iconic subscription just for guys like you. The cost of this was 56k for 1 year. After using the code NSS1 will come down to 50k. This is 46 rupees per day on physics, chemistry, and mathematics plus a guide. So this is the main advantage here. You will also get a guide here for 46 rupees per day. And for 2 years, you can use the code NSS1 to get it for 77k. Otherwise, it was 86k. So 77,400 comes out to again 32 rupees per day. So this is for those who guys who want to crack 2022 JEE, and this is for those guys who want to crack 2021. Even 6-month iconic subscription is available. The price of it will be around 38,500 for 6 months. Use the code NSS1 to get it for 34.65. All right, so awesome deals there. Okay, just give me one moment, guys. So to end the so let's go back to the problems. All right. So this is about it. Now, general concepts and problems in current electricity. We will discuss a few formulas at a glance. Okay, this is going to be a few formulas we will be discussing at a glance. This is formulas at a glance for you. So one thing we know, V is equal to IR. This is the most standard thing, and we know I is equal to NEAVD, where VD is drift velocity, A is the area of cross section, N is density per unit volume, and E is the current. E is the charge of an electron. So what do we get? We get I is equal to NEAVD, and we also know V is equal to IR. This is a very standard formula. And for series, we know that the current, the resistances will be R1 plus R2 and so on. And in parallel, we know resistances are 1 by R effective. It will be 1 by R if equivalent will be equal to 1 by R1 plus 1 by R2. We discussed many kinds of shortcuts like bridges. We discussed Wheatstone bridges. We discussed power. Power is V square by R. So we know Wheatstone bridge is also R1 by R2 should be equal to R3 by R4. And we know Kirchhoff's current law and loop law. Very important points these are. So these are a general understanding of what all concepts are there. So now let's jump into few problems. Okay. All right. These questions, from now the questions will all be very analytical. So I hope you guys understand it and solve it as fully as possible. Let's see if you can solve it faster than me. Figure shows thick copper rod X and thin copper rod Y. This rod is copper. Both of them are made of copper, but this is thick and this is thin. X is thick and Y is thin. They carry current A, which is sufficient to make Y much hotter than X. From this, we get Y is much hotter than X. Okay. Which of the following is correct? Density of conduction of electrons. Density of electron conduction is nothing but J. J, no, it's not J. It is density of current electrons. The density of conduction electrons. The density of conduction electrons is N. Now N will depend on what we discussed. It will depend only on material. So if material changes, the density will change. But even if you take let's take a small piece of wood or a wide piece of wood, wood is wood. No, the type of wood will remain same. More examples. You take one bundle set of papers or one single paper. Both of them have same number of lines. If you take a ruled book like this, yes, best way. Take a ruled book like this. Take one page. The number of rules are same. But you take any page and across all pages, the total number of ruled books are also same. Yes, correct. Saket, dissipated power means is equal to power power which is lost in the form of heat. Power is lost in heat. Now this heat can be used anywhere. So if this dissipated power is used, it is not totally wasted. Though it is not entirely used, like the efficiency is only around 40%, but then power dissipated will be power lost in heat. This lost in heat can be used. That is what we use. That is what is used in the normal in bathrooms. You have that geysers and all. Geysers are based on this heat. Hello Naveen, welcome. Naveen, today we have the quiz show, man. Today we are going to have, from today we'll rock the quiz show. All right. So yes, let's go for it. Power dissipated is power lost in the form of heat. So we are having lots of problems. So I want you guys to answer as much as possible. Okay. So N is dependent only on the material. So will N be different for both of them? No, it will be same for both of them. So option D is eliminated. So what are we left with? We are left with options A, B, and C. Time of collision between electrons. So what is heat generally? Heat is nothing but energy lost. How is energy lost? Due to collisions. Simple. I won't even think another step. It is just straightforward. How is current produced, heat produced in a wire? Because if the current, more electrons are colliding with each other, more current will be produced. Understood? When if the resistance is more, which means so with the collisions are more heat energy will be dissipated. Because more collisions will happen, then automatically more heat energy will be produced. So due to collisions, heat energy will be lost, and due to collisions, how much heat is lost? So more heat is lost. We know Y is much hotter than X, which means more collisions in Y than in X. So more in Y than in X, which also means less in X than in Y. So what is the option answer for this? The answer is A. The correct answer is A. Very good. Awesome, guys. All right, let's go to the next question. Is it clear, everyone? All right, now. So this is one very awesome question. Okay, it's a very kick-ass question. So I want you guys to pay attention. The potential divider is used to give outputs of 2 voltage and 3 volts from a 5 volt source. If this is 0 and this is 5, this is giving 2 volts and this is giving 3 volts potential. Okay. So which combination of resistances give the current voltages? One thing we know, it's a potentiometer. So the potential divider, this is at 2 and 3, 3 and 2, which means potential difference across this will be how much? 2 volts. Potential difference across this is 1 volt. Potential difference across this will be again 2 volts. And since they are in series, since they are all in series, we can say that resistance 1 is to resistance 2 is to resistance 3 will be proportional to V1 is to V2 is to V3, which is how much? 2 is to 1 is to 2. Which options has 2, 1 and 2? Wow, we got the answer directly, which is option B. Clear, everyone? यस, वेरी गुड। मतलब R1 R2 R3 एकदम सीरीज में है, तो इसका मतलब वही है कि दे विल ऑलवेज there will be no extra current flowing out because it is taken to be 2 and 3. It is found to be 2 and 3 using potentiometers. Ratio, all you can take is ratio of potential differences, and that will be equal to the ratio of resistances. Simple है, 2 is to 1 is to 1 है. This is not 1, this is 1 is to 1 is to 2, 3 is to 2 is to 2, 3 is to 2 is to 3, 2 is to 1 is to 2. बस ratios find out कर तो हो गई बात. All right, now let's go to the next question, guys. Wow, this is a very nice question. So I will solve this problem now. Resistance of all wires between the adjacent dots is R. Each of them is R. The equivalent resistance between A and B, as shown in the figure, will be. So इसमें मैं I will use a lot of symmetry here, guys. I will use lot of symmetry. तो इसमें पहला first symmetry I would like to apply here is across from A to B. If you see, the whole system is symmetric. If you observe, the whole system is symmetric about AB. तो इसमें क्या करेंगे? We will just remember equidistant potential points. We folded the star. We folded the star and solved it. We folded a body. We folded a diagram and solved. The same way here also, when there is symmetry across AB, I will fold this whole thing. And before I fold also, let me tell you, this point and this point are symmetric about A and B. So it means this resistance I can neglect. I can neglect this resistance. तो ये रेजिस्टेंस चला ही जाएगा, एकदम सीधा इसको निकाल दूंगा. एंड देन बिकॉज इट इज सिमेट्रिक, नो everything else there will be current flow, but across this will be symmetric, because here there are two resistance and 2 and 1, there will be some current flowing through this, because here double resistance current, here single resistance. Similarly here also there will be 2 and 1, 2 and 1, but across this there will only be 1 and 1, so this can be removed. Now if you simplify, bring it to the other side. Now every joint has a corresponding image, right? Every point has a corresponding image on the other side. Every joint has an image on the other side. So everything can be connected to in parallel with the other circuit. So each resistance will become half. So you can directly say each R will become half. So अभी तक R है, तो now let me draw the diagram now. I'll just draw one side of it. Wow, must draw कर लिया मैंने. Each one will become half. तो ये R/2 हो गया. Everything will become R/2 each. R/2 each. Clear है? So everything when it becomes R/2, this will become R/2, this will become R/2 and R/2, which is R. Similarly, this will become R/2, R/2 and R/2, which will become R again. So now how will it be from A to B if I draw? It will be on resistance. It will be on resistance. It will be on resistance. This is B. On top with R and R. R/2, R/2, R and R. This will be R/2. So effective resistance will be R/2 plus this two, this both are in series. You can also remove this because no current will be flowing between this and this. So I can just remove this part also. So I can write R/2 into 2R into R by 2R plus R, because this will become 2R and this will become R. 2R into R by R plus R. So it will become R/2 plus R by, which is coming out to how much? 2R into R, 2R by 3, which is coming out to how much? Take by 6 common, 3 plus 4, which is 7R by 6. So the answer is option B. Great job, guys. Yeah, this is a wonderful solution to this Simple, very awesome concept. So if you like this or anything in this video, just hit the like button right away. All right, yes, thank you guys. Hit the like button right away and share this everywhere. Okay, I want you guys to share this everywhere you go. Okay. So now another question here is given. How will the reading of ammeter of the figure be affected if another identical bulb Q is connected to parallel to P as shown? The voltage is maintained at a constant value. The voltage across the mains is maintained at a constant value. This is fixed. What will happen to the reading of ammeter? एमीटर के लिए भी एक रेजिस्टेंस होता है ना, we'll call it R, we'll call this R device, and we'll also call this R device, or I'll just call this R and R. I will call this R of ammeter. It will be very less, but it will be there. No, it is non-zero. So now let's solve it. Initially it will be like this: R ammeter and R. So directly we'll get I will be equal to V by R plus RA. And finally, when they both are connected in parallel, it will effectively become R by 2. No, if you see like this, RA will be still this much, and this will become R by 2. So I effective will now become V by R plus RA plus R by 2. So if you observe carefully, if I take 2 multiplication, it will become 2 times V by 2 RA plus R. I1 is equal to V by RA, R plus RA, and I2 will be equal to 2 times V by 2 RA plus R. So if you observe carefully, this is almost double but not double enough because the ammeter has a resistance. It is slightly less than double. Reading will be doubled of the previous version, matlab almost doubled hai, par yeah, ideal case it is given. So if it is not ideal case, we can say that I1 will be greater than 2I2. Because when the effective of the entire circuit will be changing, then the reading will change accordingly. All right, so great one. Now this is a very nice question, guys. In which of the following arrangements of resistance of the ammeter M, which is placed has resistance and has a resistance of 2 ohms, give the largest reading when same potential difference is applied across the circuit? When same potential difference is maintained across the entire circuit, the ammeter M has a resistance of 2 ohms. When will the reading be maximum? Simple, no? When will the reading be maximum? Reading is maximum when the R effective will be minimum. Reading will be equal to maximum, which implies when R effective is minimum. Understood? तो ये भी नहीं मतलब R effective की बात भी नहीं, बस यहाँ पे समझ लो कि ये 2 ohms है, तो ये 2 ohms कर लो. What is the current? हाँ, so R effective will become maximum. तो इसको solve करते हैं. Let's take potential difference to be V. So the first circuit potential difference is V, and the R effective is 1 plus 1 plus 2, which is 4. So we get current meter will be equal to V by 4. And in the second case, first case, in second case, they two are in parallel with this, and so the effective resistance here is 2R by 3, 2 by 3 plus 2. So R effective will become 2 plus 2 by 3, which is 8 by 3 ohms. So I will become 3V by 8, which is still greater than this, but not, we don't know. And from P to Q directly, if you observe, from P to Q there is direct connection to the ammeter. So if it's connected directly to the ammeter, the potential difference across the ammeter will be equal to 0. Potential difference across the ammeter will be V. So I across the ammeter will directly be equal to V by 2. No other thing can beat this. एकदम सीधा आ जाएगा, because anywhere you see, if it is connected in series with any other system, when ammeter is connected in series with any other system, the current will definitely be less. Okay, but if it is connected in parallel, or if it is connected across the whole system itself, then it will give maximum effect. So only by seeing I can say the answer is C. By seeing, I can say that the answer is C. C. Okay. Yes, hello Tarun Reddy. I'm cool man. I'm awesome. As good as ever. तो अच्छा इसमें एक बार ये क्वेश्चन को let's solve. An electric current flows through and along an isolated insulated strip PQ of a metallic conductor. The current density in the strip varies as shown in the figure. The current density is changing. The current density is changing as shown. Okay. Which of the following could explain the situation of it? Now you know it's flowing through a current, which means I will be same. But I is what? I is current density into area. So now J is reducing as you go, which means area should increase as you go along along the strip from P to Q, which means at P the area will be minimum and at Q the area will be maximum. Which of the following is the right answer here? At strip P the area is strip P is narrower than that of Q. All right. And one more thing we have to understand here is that's it. Answer is A. So I hope it is adequately clear. Okay, it's okay, Tarun Reddy, but definitely hit the like button and share it everywhere, guys. If you're doing the recorded sessions, share it everywhere. All right, it's okay. Like I know it is tough for everyone to follow, especially in these tough times. So definitely don't forget to share it everywhere so that everyone who misses on classes in this situation will have a chance to look at these. And definitely any feedback you have, put it in the comment section below. All right. So yes, and don't forget to like the button. Like also, of course, like button should be mandatory. All right. So is it clear? So I is same. It's given clearly that the current density of strip. So I is same because for a given strip, conservation of charge. जो current अंदर यहाँ से it will come. The same current will flow out from the other side. So I will be same, but J is changing. So how is J is changing? J is decreasing, which means area should increase. Okay. Oh wow, this is a very nice question, guys. Let's see. We'll solve this. A candidate connects a moving coil voltmeter, a moving coil ammeter, and a resistance R as shown in the figure. The voltmeter reads 20 volts and the ammeter reads 4 amperes. The ammeter is reading how much? It is reading 4 amperes. And the resistance R will be. So whatever ammeter will show the correct resistance. No, correct current. Ammeter will not show the wrong current. So the total current flowing will be equal to 4 amps. Okay. And so one more thing, the current flowing through this will be less than 4. It will be somewhere like I will be equal to some less than 4. Let's call it I1. This will be 4 minus I1. Utna hai. That is how the situation is. Now this voltmeter is reading the potential difference as 20 volts, which means 20 volts will be equal to the potential difference across is equal to I1 into R. 21 volts will be equal to 20 volts will be equal to I1 into R. From this we'll get R is equal to 20 by I1. We know I1 is less than 4 amperes. From this we will get resistance is greater than 5 amperes. Otherwise the product will not become 20. So one thing we know, it is greater than 20 amperes. एकदम एक बार समझ में आ गया concept ना तो just apply everywhere. So I hope I'm clear to you guys. Yes, very good. All right, now let's go to the next question. This is a very nice analytical question. I want you guys to understand total heat generated also based on current. So in this given question, time varying current is passed through the resistance as shown. The total heat generated. What is the total heat generally? It is I square RT, right? The total heat generated will be I square R. It is power is I square R, no? So what do we know heat is? Integration of P dt. So that's what we'll do. Integration of I square R dt. That is all we are going to use. This is the only formula we'll use here. R is already not given, so we'll take R to be standard R. T naught is each individual T naughts and I square. So in this particular from 0 to T naught, the I will be given by, it's a slope, right? I will always be given by x by T naught into 3I naught, 3I naught. At T naught time we have 3I current. At x time at I current will be equal to x time x by T naught into 3I naught. So what is I square equal to? 9 I naught square by T naught square into x. X is nothing but along the distance, along time. Time is equal to x. So into x square भी आ जाएगा. तो इसको कितना, so I square r dt से कितना हो जाएगा, I square r dt में dt is nothing but dx in this particular case. तो इसको मैं t कर दूंगा. I'll make this as temperature is equal to T. So I square R it will be equal to I square by T naught square. तो सीधा इसका क्या आ जाएगा आंसर, 9 I naught square into just I square will be equal to 9 I naught square by T naught square into T square. Just substitute the whole thing here. Now power will be equal to integration of 9 I naught square by T naught square into T square into R into dt from 0 to T naught. And from there it is become very straightforward. So let's just solve this. कितना हो जाएगा, 9 I naught square by T naught square into R into T cube by 3. तो T naught cube by 3 हो गया, सीधे यहाँ से 3 बार कट गए, तो यहाँ पे स्क्वायर कट गया, तो I am getting 3 I naught square R into T naught is the power in the first case. And from the second case I can just add off. The second case is constant current of 3 I naught, so the power will be 9 I naught square into resistance R into time of is T naught. And the third case is T and T. So I'll get I naught square into R into T naught. You add the whole thing, what am I getting? 13 I naught square R T naught, because this is 3 plus 1 which is 4, 4 plus 9 is 13. 13 I naught square R T naught is the current here, is the total heat generated here, guys. So this is one very nice formula which we did not use till now, but you can know. Power is I square R, which is equal to dW by dt. So dW will be equal to integration of I square R dt. Yes, voila, simple. I hope you like this session. So if you like this, definitely don't forget to hit the like button, guys. Great. I'm pretty sure those who've done it know the concept very well. Okay, ye must question. A cell of internal resistance 1 ohms is connected across a resistor. A voltmeter having a variable resistance is used to measure potential difference across the resistor. Okay, the plot of voltmeter, its voltmeter is used ideally, ideal voltmeter is used high variable resistance. Matlab we'll take it to be ideal case. Okay, the plot the voltmeter of V against G is as shown. What is the value of external resistance R? So ये resistance का value कितना होगा? He is saying initially the potential difference is 0, but as the current flows, the current finally it is settling at 20, which means whatever current is flowing here, we know I into R will be equal to 20 ohms, and I into R plus 1 is equal to 24. Just divide both of them. R by R plus 1 is equal to 5 by 6. एकदम इसको कॉम्पोनेंट कुछ भी नहीं करूंगा, सीधा लेट R is equal to 5. समझ में आ रहा है? एकदम सीधा लिख सकते हो. The moment you see this, you can solve it and go for it with a very nice smooth manner. All right. So ये हो गया. ये this is one of those very interesting questions. 3 bulbs of 60 volts, 120 volts are connected across a 120 volt power source. If the resistance of each bulb does not change with current, then find out the total power delivered by the 3 bulbs. Each one has 60 watts by 120 volts, and we know for the given resistances power will be proportional to V square because the R is same. Okay, so now power will be proportional to V square. If I find out the potential difference across each of them, I can directly solve each of them accordingly. So now I have one resistance like this, same resistance across this and across this. So what do we know? The effective R effective will be equal to R plus R by 2, which is 3R by 2, and I will be equal to 2V by 3R, which is also equal to 80 by R. So we'll not go into the in-depth values, but I will be 2 times this by R, which is nothing but 2 by 3 times नॉर्मल करंट. नॉर्मल करंट में 60 वॉट्स आता है, तो 2 by 3 टाइम्स जाएगा तो 60 वॉट से कम आएगा, राइट. which can also be in power is also proportional to I square. तो इससे भी सॉल्व कर सकते हैं. It is equal to I square into R. No, R is same, we can directly write power proportional to I square. So I'll name this bulb as 1, 2 and 3. Bulb 1 has current is equal to 2 by 3 times I naught, which implies power will be equal to 2 by 3 whole square times P naught. Is 4 by 9 P naught, and that gets distributed equally among both of them. B2 and B3 will have I is equal to 1 by 3 I naught, So power will be equal to P naught by 9 each. Total power कितना हुआ 4 P naught by 9 plus 2 into P naught by 9, which is 6 P naught by 9, which is nothing but 2 P naught by 3. जो जितना ओरिजिनल पावर है उसका by 3, 2 into 3 by है, तो 2 into 60 by 3 will be equal to 40 watts. What? 40. I hope you understood this question, guys. So we'll be doing lots and lots more of problems. So stay tuned, definitely. An apparatus is connected to an ideal battery as shown. Ideal battery में internal resistance नहीं होता है. For what value of current power delivered will be maximum? So one thing we know already, power delivered is maximum when R internal will be equal to the R of the apparatus. So in this particular case, what will the whole condition be? Then R equivalent will be equal to 2R, which implies the current will be equal to E by V by E by 2R. Current will be E by 2R. So what is the potential? Simple ना, एकदम सीधा हो गया. Simple से यार, this question is very straightforward. We got of the current to be equal to E by 2R, which is the correct answer. Very sahi, बहुत सही, बहुत सही. Now this is the trickiest, and I think this is the last question of the day before we finish it, because we are having 1.5 hour sessions, so almost time khatam ho gaya. We will definitely continue with this. We'll have loads more, many more problems tomorrow. All right. In the given black box of unknown EMF sources and unknown resistances are connected by an unknown method, such as one, when terminals 10 ohm resistance are connected to the box, then 1 ampere current flows. And when 18 ohm is connected to the box, 0.6 amperes flow. So इसमें बहुत simple सी concept है. इसका internal resistance एक ले लो RI and VI करके ले लो. And now across 10 ohm resistance, if you take, the current is 1 amp. So what do we know? VI by 10 plus RI is equal to 1, which implies VI is equal to 10 plus RI. And similarly, if you put RI is equal to 18 amps, we will get VI by 18 plus RI is equal to 0.6. From this we will get VI is equal to 18 plus 0.6 RI. 18 into 0.6 plus RI is 0.6 RI. So इस दोनों को, yes, you can solve it by multiplying this with 5 by 3 or divide or multiplying this with 5 by 3. Let's multiply this with 5 by 3. We will get 0.2 into 5, 1. 18 minus 18 plus R2 is equal to 2 VI by 3, which is how much? It is 10 volts, no? Alright, we will write it as VI. Just give me one moment, guys. Both of these are equal, no? Let's just equate both of them over. What am I waiting? 10 plus RI is equal to 10.8 plus 0.6 RI. So 0.4 RI is equal to 0.8, which means R internal is 2. We got of the R internal. Now substitute it here. What is the value of V internal? It will be 12. We got V internal as 12. Now what did we get here? We got, arey yaar. So these are the questions I'll be having tomorrow. And this is a very small issue I have here. So I got V is 12 volts and RI is 2. So for what value will the current flowing through this be 0.1 amperes? So simple, I'll just find out that value now. 0.1 will be equal to 12 by 2 plus R. R plus 2 is equal to 120. R is equal to 118 ohms. That's it. Simple. Answer A ho gaya. So that's it for today, guys. So don't forget to crack IIT-JEE in English. Share this video if you like it. Even if you don't, you just share this everywhere so that we can make this viral. This is for everyone who has trouble understanding Hindi, South India especially. Hindi में problem है because lot of videos I see are in Hindi. So Hindi में if you have a problem, we are going to do it in English here. So don't forget to use the code NSS1 while taking the plus subscription, where everything is rosy and you get the best of Unacademy. Don't forget to hit the YouTube comment section, hit the bell icon, and subscribe to this channel, Crack IIT-JEE in English, so that we can reach more and more students like you guys. So that's all for. So until See you. Bye bye.